All right, so we are starting transformations today, and the first lesson is going to be on vertical and horizontal translations as well as stretches. So the translations are pretty easy, the stretches are a little more difficult. So first of all, a vertical translation, you would have done this in like grade 6 math. You're just moving a graph up or down. Horizontal, you're moving a graph left or right. The first thing I actually want you to do is I want you to take that formula sheet out, because this formula will be referring to this entire next 3 or 4 lessons. So we're going to be using it quite often. All right. So the two parts that you need to worry about for now is your K value is your vertical translation. So the K value tells us how much our graph is moving up or down. The H value tells us the horizontal translation. So it tells us if the graph is moving left or right. So what this formula means is you're taking a function. So maybe I'm taking a function of x squared. So let's say f at x is x squared. Okay. If I were to move that function up, I'd add the K value up. So you would replace that f function with the x squared. So this would mean I move my graph up 5 units. Okay. The H function, what that means is you're actually replacing the x with that function. And the sign is always opposite. So if I have x minus 2 here, it would mean I'm moving 2 to the right. When I have x plus 2, it would mean 2 to the left. So if you were to take your function, okay, and you replace the x with x minus 2 squared, that would show a horizontal translation. So the key is vertical translations, it's almost like you tack them on the end. Horizontal translations, you're replacing the x with whatever that translation notation is, that replacement notation. Okay, so let's just start by looking at some graphs. Okay, so if we were, and actually in your notes, I think we start here. So let's actually start here. So it says describe the transformation of each. So here we're replacing the x with x minus 3. So when we look back at that formula, and you may be wondering, well, what do those other letters mean? We'll get to that. Don't worry about it. Right now for the translations, we're just worried about the H and the K. Okay, so because the x is replaced with x minus 3, so it's in brackets, it's part of that f function, that's a horizontal translation. And remember, it's always opposite to the sign. So we would just say that we move 3 units right. Here, notice how that 5 is tacked on the end. So that's a K value. You're not replacing the x, it's just added on the end. So that's a vertical translation. So in this case, it's 5 units up. So our horizontal translations will always be opposite to the sign. That's kind of what you're thinking, opposite. The vertical translation is always what it seems. Okay. This next question though, notice how that y variable is not isolated. So we do want to isolate that y variable first. So that means we're going to add the 1 over. So now we see that there's a horizontal translation, right? Because that f at x is replaced with f at x plus 10. So that means we're moving 10 units to the left because we changed the sign. And then the positive 1 shows us a vertical translation. So we're moving 1 unit up. So we have a horizontal and a vertical translation. All right. Also, what you will see is mapping coordinates. We use mapping coordinates a lot in this unit. So if we wanted to use mapping coordinates and we're moving 3 units left, our mapping coordinates would actually look like this. We would go x plus 3, but then our y didn't change. It didn't move up or down, so it would just stay as y. So this would be my mapping coordinates. Okay. Here, your mapping coordinates would be x would just stay the same, and then your y, you'd be adding 5 because you're moving 5 up. And then lastly, your mapping coordinates, okay, you're moving 10 left, so it'd be x minus 10. And then your y value would be y plus 1 because you're moving, 10 left, so that's why it's x minus 10, and 1 up, which is why we have y plus 1. If you're wondering what mapping coordinates are, you may have seen them before in previous grades, but pretty much they tell us exactly what happens on the graph. So if I were to take, say I had a point of 1, 1 on my original graph, and this translation happened, okay, I would input that 1, 1 into my mapping coordinates, and I know after the translation, this point would move to 4, 1, right? Because you would just substitute the x, the 1 in for the x. And the y, of course, would stay the same. So mapping coordinates tell us the new point after a transformation, which is super handy when you're doing like 3 or 4 transformations at a time, which we will see at the end of this unit. Okay, and we'll go to this one, pretty straightforward. Again, always make sure your function is isolated. So this means I'm moving 1 up, so I just draw this graph, boom, move 1 up. Here, because that's in the function brackets, we know it's a horizontal translation, so we are moving left 1, right? Always opposite sign, so we just take our graph and we move left 1. Oh, I didn't do a very good job drawing this. Let's try that again. Left 1. Yay! And then last one, we're moving 2 right and 1 down. So then each of your points you would move 2 right and 1 down. Okay, you get the gist there. This is pretty small. We already talked about what mapping notation is. In your workbook, you'll see replacement notation. You won't see that on any quiz, test, or diploma. Mapping notation will be the more heavily what we'll actually be using, but the workbook uses replacement notation, which is why I wanted to discuss it. What replacement notation is you're just replacing your x with x minus 2. So it's just what you're replacing your variable with in your function equation. Okay, so let's look at a few diploma questions. So given the functions f of x equals the absolute value of x minus 2 plus 3 and g of x equals x plus 2 plus 1, the transformations that will transform f of x into g of x, or a translation of. So pretty much they're saying, how do we translate this graph into this graph? Okay, so there's a few ways you could do this. You could definitely try graphing the two equations, okay, and then looking at the difference. I'm going to just look at the formula here. So these formulas look pretty much the same. So what we're doing is we're taking our f function though, and in order to end up with this equation, we're going to have to replace that x minus 2 with x plus 4, right? And the reason is because I'd have to replace the x with x plus 4, because then I'd have x plus 4 minus 2, which would give me that x plus 2. Okay, and then I would tack on a negative 2, right? In order to get from positive 3 to positive 1, you would need a negative 2. And I will show this to you in a minute here. I'm just going to go my negative 2. Okay, so just to kind of show you that it does work, if you were to take this f function, in order to end up with our g function, this is my g function equals, we would take our f function, replace the x with x plus 2, x plus 4 I mean, sorry, and then tack on the negative 2. So x plus 4 minus 2 gives us x plus 2, and then positive 3 minus 2 gives me a positive 1. So that's my goal here, is how do I transform that equation to end up with a second equation? Okay, this is my transformation formula, so that means we would have to move 4 units left and 2 units down. So my correct answer would be A. All right, next question. This next one's a little easier. That last one, you have to do a little bit of backwards thinking, so it is more of a problem-solving question that requires that thinking cap. So the point 2, negative 3 lies on the graph y equals f at x. State the coordinates of the image of this point under the following transformations. So we know this means the graph is going to move 7 units right. This means the graph is going to move 5 units up. Okay, Okay, so if I wanted to write my mapping coordinates, and I just like kids to get into the habit of writing those mapping coordinates because they make such a big difference later on when we start combining transformations. Okay, I'd have x plus 7 and y plus 5. That's what my mapping coordinates look like. So now I just substitute that original point. So 2 plus 7 is 9, and negative 3 plus 5 is positive 2. So then the new point would be 9, 2. So now we move into stretches. These are a little more difficult. So a vertical stretch, you're always stretching from the x-axis, and that can be confusing to kids. So you're kind of thinking of your x-axis as a reference point, and you're taking each of your points, okay, and you're multiplying them by whatever your stretch is. So in this case, I have a vertical stretch of 2. I'm taking that point from that x-axis and timesing it by 2. So that x-axis is your reflection. So it's almost like if you were to take this graph, okay, you would be vertically stretching it. So you'd be stretching it from the x-axis. So your new graph would look like this. So it's like I'm stretching it from that x-axis. Okay, so that brings us to invariant points. Because we're stretching from the x-axis, our invariant points would be any point on the x-axis because you're stretching from the x-axis. So really you're thinking of timesing all of your y variables by that vertical stretch. If you times anything by 0, you'd end up with 0, so you wouldn't change. And any number or any coordinate on the x-axis would have a y variable of 0. Okay, so if I were to vertically stretch that, I'd end up in the same point. So what an invariant point is, an invariant point means even after a transformation, that point does not change. It stays in the same place. Okay, so a horizontal stretch is a stretch from the y-axis. So with a horizontal stretch, this time you're stretching from the y-axis. So all your x variables are going to change. They're going to be multiplied by whatever that horizontal stretch is. The other thing you need to watch out for with horizontal stretches is you'll always be taking the reciprocal of the b value. So the b value is not my horizontal stretch. The b value, the horizontal stretch will be the reciprocal of the b value. So if my equation looks like this, y equals f at 1/2 x, my horizontal stretch would actually be 2 from that y-axis. Okay, so always think of that flip, and always remember the horizontal stretch, it's going to affect your x variables, and you're stretching from the y-axis, sorry. So that means because you're stretching from the y-axis, your invariant points would always be any point on that y-axis. Okay, so this just relates to your formula. So the vertical stretch is always going to be your a value. The horizontal stretch is always the reciprocal of the b value. Okay, so you could draw what they would look like. So here I have a vertical stretch, and then we should, I keep meaning to fix this. Okay, you should still have that function notation. So we're vertically stretching by a factor of 2. That's how we would write that. And I will be picky about that. So vertical stretch by a factor of 2 along the x-axis. Okay, that's what we would say. So all my invariant points would be on the x-axis, and all I do is I take all those y variables and multiply them by 2. So that's my new graph. Okay, so here this would be a vertical stretch of 1/2 along the x-axis. Same thing, all my invariant points would be on the x-axis, and I'd be multiplying all my y variable values by 1/2. So that's what my graph would look like. Here, okay, that is a b value. So remember, we take the reciprocal of that to find our horizontal stretch. So we'd have a horizontal stretch of 1/2 along the y-axis. And I am using abbreviations here just because I don't have a lot of room to write in, but when you write on your test, I want to see the correct terminology. I do not want to see abbreviations. Don't be lazy. Okay, so then you would be taking all your x values and timesing them by 1/2. So it would look like that. Okay, here my horizontal stretch would be of 2 along the y-axis, because the reciprocal of 1/2 is of course 2. So my invariant points would be any point on the y-axis. I like to start with those invariant points. And now I'm going to take all of my x values of each point and times by 2. So then my graph looks like this. Yay! Okay. So now all we're going to do is describe some transformations that occur here. So this first one we would say is a horizontal stretch by a factor of 2 along the y-axis. And again, I'd like you to practice writing those mapping coordinates. So because it's all your x values being multiplied by 2, your mapping coordinates would be 2x, y. Okay. The next one, because the 3 is in front, right? Notice how the 3 is in front. It's not replacing the x, or else it would have looked like this. It's in front. So that means it's a vertical stretch. So it's a vertical stretch by a factor of 3 along the x-axis. And if I wanted to write mapping coordinates, okay, it's all your y values being times by 3. So it'd be x, 3y. And then lastly, the 2's in front. So that is our vertical stretch. So we have a vertical stretch of 2 along the x-axis, sorry. And we have a horizontal stretch of 3 along the y-axis. So then my mapping coordinates, I'd be multiplying all my x variables by that horizontal stretch, which would be 3x, and all my y values by the vertical stretch, which would be 2y. Okay. All right. Now, before we move on, I am going to point one more thing. So on your test, and I'll definitely do this to you, and on the diploma, sometimes instead of saying y-axis, you will see the line x equals 0, because they're the same thing. It's just another way of saying that. And instead of saying the x-axis, you will see the line y equals 0. So make sure you feel comfortable with both of those terminologies. Okay, let's look at a quick diploma question here. So we have 2 different graphs, and it says what kind of transformation took place. All right, so I like to kind of start with some points. So I'd probably start with the y-intercepts. So I know the f is my original, and it's transformed into the g. So the f, I started at 0 and transformed to 4. And I know with all my options here, obviously this is a stretching question. There's no translation. It is a vertical and a horizontal stretch. And then I end up with 0, 8. So that tells me there's probably a vertical stretch of 2 in order for me to get from that 4 to 8. Now I'd also look at the vertex. So my original graph had a vertex of 1, 2, and my new graph had a vertex of 3, 4. So again, we see that vertical stretch of 2, but we also see a horizontal stretch of 3. So all those x variables are getting times by 3. Okay, so I have a vertical stretch of 2 and a horizontal stretch of 3. So now we're trying to figure out, well, which of these equations shows that? So remember, the vertical stretch of 2, that's your a value. That's the number in front of your function. So we know it has to either be b or d then. The horizontal stretch of 3, remember with horizontal stretches, the b value is flipped. So we're looking for the 1/3 where that b value would be. So then that means our answer is D. All right, here's our last slide. Create the mapping coordinates and equation of the following graphs from f at x to g of x. Okay, so this green graph is your g of x, the f at x is your original. So right away I can tell there's a vertical stretch because you can see that f at x graph was stretched outwards. So I'd probably I like to focus on key points. I'd focus on that x-intercept. So notice how my original graph has an x-intercept of 1, 0. My new graph, 1, 2, 3, 4, would have an x-intercept of 4, 0. So I would probably say there's a horizontal stretch then of 1/4. Or sorry, a horizontal stretch of 4. Oops. So then my mapping coordinates would be 4x, and the y would stay the same. The function equation, because you'll always be asked one of the three. You'll asked to describe it in words using correct terminology. So I would say a horizontal stretch of 4 along the y-axis. You'll be asked mapping coordinates, or you'll be asked for that function equation. So the function equation would be f at 1/2 x, just like that. Here we go. Okay, and the next one, again, I'd probably key on some key points. I know it's a stretch and not a reflection or a translation because there is an invariant point on the origin. Okay, so I'd probably focus on these points. So my original graph has an x value of 1 and a y value of 1. My new point has an x value of 3 and a y value of 2. So just looking at that, I would automatically guess the horizontal stretch would be of 3 and the vertical stretch would be of 2. However, don't be lazy. Don't stop at one point. I would check all of these points, or at least probably 1 or 2 more, and make sure that was true for all the points. So that's a big mistake I see kids do. Don't get lazy. So now that we know what's happened here, we can write our mapping coordinates. So my mapping coordinates, because I have a horizontal stretch of 3, would be 3x. A vertical stretch of 2 would be 2y. To write my function equation, okay, the 2 would go in front of the function because it's my a value. And I would take the reciprocal of the 3 for my b value. That was a lot today, okay? And the good news is we're going to look at this quite often before your unit exam. So the first day today hopefully made sense. Let me know if you have questions, and definitely do some practice.